Hello friends, today I'm gonna talk about theory. At the request of some subscribers I will tell you about some special cases of parallel connection of resistors, capacitors and inductors. So let's draw the cases that I will talk about this video. So the drawing is ready. In order to make it easier to explain, we will agree that we will use an electrical circuit for DC current. This will make it easier to find equivalent resistance, equivalent capacitance and equivalent inductance. In these three cases, the law of conservation of electric charge will form the basis. As a consequence of this, the first Kirchhoff rule, which says that as much current flows into the node, so much current flows out of the node. For the first case, I will also use Ohm's law on the part of electrical circuit. Also, I hope you know what the electric voltage is. Ohm's law. Electrical voltage is the work of moving an electric charge from one point to another. This work is independent of electrical resistance. Therefore, I have the right to say that the electric voltage between the nodal points is the same. I'll write it. As I said earlier, that first case is based on the law of conservation of electric charge. The consequence of this is that the currents in the nodes are summed up. I'll just express the current range in terms of Ohm's law and rewrite it a little differently. Look at this. This is basis, and and I want to get this. Now both parts of the equation need to be divided by voltage. And as a result you get this familiar formula. Now the second case, which the capacitors. Since the capacitors does not pass direct current, I will use only the law of conservation of electric charge. How much charge flows into the node, the same amount flows out. I'll write it. Q Q1 Q2. As in the previous case, the electric voltage between the nodal points is a constant value. I'll write it. I will also use the definition of the electrical capacity of capacitor as the ratio of electric charge to voltage. Say Ezekiel Q per U. It remains to express the charge in terms of voltage and capacitors as follow. You see, please. We also divide by voltage and get a ready-made formula. As you can see, in this case, the equivalent capacitance is equal to the sum of the capacitance of the individual capacitors. And finally, the last case, which inductors had to their currents add up at the nodes as in the first case. I'll write it. I1, I2. This is a consequence of law of conservation of electric charge. In the same way as in the previous cases, the voltage between the nodal points is the same. As a result, we can say that the magnetic flux does not change, since the magnitude of the magnetic flux depends on the current strength and properties of the conductor. In this case, the inductor. I'll write it. Consequence. Magnetic flux. Now it remains to remember how the magnetic flux is related to inductance and express the current strength. I'll write. Consequence. And I'll write this. V per L1 to divide and I get familiar formula. That's all for now. Thanks for watching me. Yuri Kovalyonok was with you. If you have any suggestion, write about it in the comments. Bye bye.